Hello, this little section will show you how to use the amortization feature of the graphics calculator. It allows you to do some more complex things with future value annuities. With any question, it's possible to use the calculator to solve many aspects of it, and it gives you great flexibility to work out different things to do with interest, balances, outstanding balances, and things like that. We use the AMT button, which is the amortization button, which is F4. That then brings up another window, which gives us the ability to do a whole lot of other things. The difference in the windows is that there's a PM1 and a PM2. PM1 is payment 1, PM2 meaning payment 2. It will do any calculations between those two payments. Things like the balance, outstanding balance, interest earned, or interest in a payment. The best way to look at it is in a question. So you're putting $250 per month away for 45 years in an account that pays 5.75% per annum, compounding monthly. Money exists in the future, regular series of payments. So it's an annuity question, it's a future value annuity question. Part A, how much will you have at the end of this time? How much interest has been earned over the time of the investment? After 20 years, what's the balance of the account? And between the 40th and 45th year, how much interest has been added? So the first question is just a straightforward future value question. So once again, in your calculator, put in N, I, PV, payment, future value, payments per year, and compounding periods per year. 45 times 12, because it's done monthly, minus 250 as your payment. On your calculator, it will look like that, and the answer you will get will be $637,282.26. Now that starter, those numbers will stay in your calculator now for all the other calculations that you need to do. So how much interest has been earned over the time of the investment? You could work out how much has gone in your payments and take it away from your final balance and get a number. Or you could use the AMT button, the amortization button, which will help you work it out quicker. So, if you hit F4, a new window will come up on your calculator. It will have a PM1 and a PM2 in it. The rest is exactly the same. So our payment 1 is the first payment that you're looking at. So it starts from 1. Payment 2 is the last payment, so this is going to be the last payment that we have. So in this case, it's 45 times 12. What will happen is the calculations will be carried out between those two payment periods. So on your calculator, it will look like this. You'll have 1, 540, 540, and all the rest of the information will be the same. Now you've got to find the total interest. Total interest is sigma int, sigma interest, which is F4. You push F4 and you'll get an answer that looks like this. The answer is negative, but of course it is a positive number, so it's $502,282.26 in interest you've earned over the whole period of that investment. Next part of the question says, after 20 years, what is the balance? So how much money have you actually got in that account after 20 years? You might want to stop it and do something else, but you'd like to know how much you've got there. Once again, amortization. Payment 1, payment 2, N, I, PV, payment, future value, payments per year, and compounding periods per year. Fill in what you got. Number 1, payment. First payment is the one you're looking at. So PM1 is 1. It starts at the beginning years and goes up to 20 years. Payment 2 is the balance, and you're looking at the balance at the 20-year mark. So that's 20 times by 12. It'll do the calculations between those two bits. The balance is always calculated on the last number there. So when you do that on your calculator, it'll look like this, and then you're pushing F1 to get balance. When you do that, you'll get a balance of $112,149.44. That is the balance of the account at that time. Last bit, between the 40th and 45th year, how much interest has been added? Once again, the amortization. Payment 1, payment 2, N, I, PV, payment, future value, compounding per year, payments per year. They all stay the same. Payment 1 and payment 2 are the ones that you will change. So the 40th year is 40 times by 12, that's your 40th payment. Your payment at the 40th year, and the payment 2 will be the payments at the 45th year, 45th times by 12. On the calculator, it looks like that, and then you use F4 to find sigma int again. Sigma int is adding up the interest. You do that and you'll get an answer of $159,132.72.